Students, today we are going to discuss about the atomic radius of an atom. Student, the size of an atom, it has been expressed in term of atomic radius. Many of the physical and the chemical properties of an atom depends upon its size. That means it is going to depend upon the atomic radius of that atom. The atom is considered to be a sphere, and if it is so, then what is going to be the atomic radius? It is going to be then the distance from the center of the atom to its outermost shell. It is just similar as we measure the size of a ball, right? So the atomic radius, if it is expressed in term of its atomic we can say considered to be a sphere, that time let us, this is if an atom is considered to be a sphere, that time the atomic radius is just express the size of atom, right? And if it is considered to be a sphere, then the distance of the center of the sphere or center of the atom to the outermost shell. So what is the atomic radius then? It is the distance of the outermost shell from the center of the nucleus, or we can say that the atomic radius, student, it is the distance from the center of the nucleus to the point, it is the distance from the center of the nucleus to the point where the probability of finding electron is maximum, right? So the atomic radius, we can say it is expressed as the distance from the center of the nucleus to the point where the probability of finding the electron, or we can say electron density, is maximum. Students, there are certain, we can say, difficulties while we are measuring the atomic radius. Why? The first is that it is difficult to isolate an atom just to measure the atomic radius. That means it is difficult to get an atom isolated, right, to get its atomic radius measured. Second, student, that the probability density of the electron, right, is never going to be zero from the center of the nucleus. That means there will we can't say that in an atom, right, or near an atom, there's a point where the probability of getting the electron is going to be zero, right? Third difficulty is that the atom, the atomic size will be affected by the state of bonding. That means atom, if it is covalently bonded or when it is an ionic bonded, right, same atom, if it is in different bonded state, will have different atomic size, or we can say the radius, right? And next is that the surrounding of an atom in a molecule is not always same, it changes. So hence the atomic size in terms of atomic radius is been classified on the basis of whether the atom is metal, non-metal, right, and its type of bonding. It has been divided into three main types, right? First is the covalent radius, second is the metallic radius, and third is the van der Waals radius, right? So atomic radius, depending upon the, we can say, the state of its bonding, or whether the atom is metal or non-metal, right, depending upon whether the atom is metal or non-metal. Atomic radius is classified into three types. Student, first is the covalent radius, second is the van der Waals radius, and third is the metallic radius. So these are the three types of atomic radius, right, when we are talking about the nature of the atom, whether it is metal or the non-metal. Generally, this metallic radius is for the metals, and these two both for metal. These two are for the non-metal. So the metal will form the metallic radius, and the non-metals are going to show two types of radius, covalent and the van der Waals radius. Now let's discuss about the covalent radius, that how this covalent radius will be formed or how we are going to take it. So students, the covalent radius, it is taken. Now let's take here. Now let us take here. So we are talking about here about the covalent radius. So this type of radius is found in atoms which are covalently bonded, right? So let's take, this is one atom and this is another atom, right? Let it be this of hydrogen. Two hydrogen atoms are bonded together and they are forming the hydrogen molecule. Now let's see, imagine that these two are the nuclei of these two atoms, right, which are bonded by covalent bond. Now when we take the half of this internuclear distance, that is AB, student, here is the internuclear distance. So we are taking the internuclear distance, that time OA and OB will be taken as the covalent radius of hydrogen atom, right? So here the two hydrogen atom, students, are covalently bonded, right? And if it is taken to be 74 picometer, that is the internuclear distance between the two covalently bonded hydrogen atom is nearly 76 picometer. That time the covalent radius is going to be nearly 38 picometer, that is OA. Now OA is going to be, student, the covalent radius of the hydrogen atom. Okay, now just make this correction. If it is 74, so that means it is 37 pm. So now we are going to define the covalent radius. We can say it is half of internuclear distance between the two same atoms which are covalently bonded in a molecule. So what is the covalent radius, student? It is, we can say, it is the internuclear distance between the two atoms, right? The two atoms should be same. If it is hydrogen, it will be of hydrogen atom only. Two same atoms it will be, right, which are covalently bonded to one another. And we will just take the half of this distance. So student, this is about the covalent radius.